Hello there, and welcome back to Meshing with Ennova. So let's continue our videos. Okay, we're using our tool, Ennova, but everything that we're going to address is general. So any meshing tool will have similar capabilities, different GUI, okay, but pretty much we'll do the same. For I would like to address in our workflow how to generate meshes. So this is the geometry we're going to work with, still the same one, easy one, but I'm going to show you a few things. But in our workflow, okay, we're going to stick here. Later we move to OpenFOAM, which pretty much is the same. Let's talk about geometry and geometry import. Okay, so it's something that people take it for granted, but having the good format and a clean geometry is very important. So here, that elbow geometry, I save it in different formats just to show you. So coming back to the OpenFOAM community, you might be very used to the STL geometries. So here we open the STL geometry, and this is what we see here in Ennova. So as you see, the geometry has been cleaned, okay, using that the library, the kernel, it cleans the geometry. And what is very neat about working with STL files here in Ennova is that you can select the faces. So as you recall, those are triangulations that you cannot access that faces. Instead here, using the geometry kernel, we have access to that. And now you can set local refinements, okay, local refinements and faces, edges, so on, or select faces or do some manipulation, okay. And just to bring it back here, so this is what you have, okay. The STL have this triangulation, okay. So it's not the best format. I don't recommend it, and probably this is something that's coming from the OpenFOAM community that everybody use that. Instead, we should use a proper CAD format, and there are many of them. So here you have the list, all the formats. Probably the best one will be the step format or the parasolic format, okay. You have the edges that is very popular, and I will show you that it can give problems in many occasions. Then you have also proprietary format like SolidWorks, Space Green, CATIA, and so on. They all work fine, but you need to find that right format. So let's open this step format. Okay, so this step format will be here in this case. And when I open the step format, I get the geometry, beautiful geometry, and something just to stress about to show you. So see that we imported, it is a volume, means that it is watertight, okay? But look at the edges. Let me hide the surface. Everything is black, and this is very important, okay. This is a connectivity that we have. It's called double edges, okay. It means that one edge is connected to two surfaces, and means that everything is closed. So you also always should be careful about this. So you use another software, probably this step is not done, and it's assumed that okay, everything is connected, but sometimes it might happen. And just to show you when you have something that is not connected, let me open the edges geometry here. So the same geometry with the format edges. Okay, so when I open this one, look at what we have here. Okay, same stuff, but it didn't create the volume because it's not watertight, it's not closed geometry. And see that you have red edges there. Okay, it's called single edges. It means that the edge is not connected to another surface, just a single surface. So it means that there is a gap here there. So this is information that in the edges is missing, okay, doesn't work very well. And this will happen with many other software, okay. So be careful about this. So for the moment, I have to say that the STED is a very good format. Also, I recommend you to use the parasolic format. Also, it's a very good one, okay. So see that is everything is there. It's a volume, and then hey, the surface is there, everything black, what we want, watertight geometry. And to show you, let's open, for instance, we have also a space clean format, just to show you that it's very versatile. Ennova have many formats. So a space clean is another very nice solid modeling tool. It reads the geometry with no problem. And here also I have a SolidWorks, and I think somewhere I have a CATIA as well. So all those formats will work with no problem. Of these formats, no proper parametrical CAD. The only one that gave problem is the edges. So be careful about that very specific format. Just to show you another format, I really hate it as well, like the STL. We have the Rhino 3D, okay. So many people work with Rhino 3D, and In this case, it read it, there is no problem, but in my personal experience, from time to time, you're going to find small gaps or red lines there. So in this case, it worked, and here you have the geometry. And there is another final format that I want to address, very similar to the STL one. So as you recall, let me go here, you have the STL, when I open, automatically detected the edges there as well. You have that information now there that can be extracted. But there is another format called Colada, okay, or the extension is die. I recall this format because working with someone, that person was using a Sketchshot. Okay, a Sketchshot, it used to be Google's Sketchshot, now I think it's Trimble. It's a very nice tool. Okay, but it's not a proper CAD tool. So that person was working with this format, giving me the geometries, and I was having a lot of problems. I wasn't using at that time Ennova, something else, but that other application was also having problems. And let me open this one just to show you, the peculiarities about this format. So if I open, okay, and see that in this case, there is no edge information. It's just the triangulation. As you go here, triangulate, it will be similar to an STL file. So this is really bad in the sense that you don't have that information, what to follow the edges. Now remember that we're using a topology-based meshing tool. So topology-based, and let me change this color, right click here, set color, let me put something, means that the meshing tool will follow all the features, the curvature on the surface, but it will also try to stick to these edges, concentrate here in the nose and so on. In this case, we don't have that information. So any tool might have problems. So just to show you a little bit what can happen, and let's go to the meshing. So if I go here, remember they always need to create volume here. So right click, create volume. You can create a volume, no problems, okay? Everything is watertight, but we don't have that topological information. So as I go into mesh, okay, let me bring the tool. So in this case, I just interested in the global parameters, and let me go and put here 0.5, 0.5, okay? So these are my global parameters, and see how easy it is to use and all of that. Just these 3 parameters is more than enough, okay? Maximum, minimum, and curvature. Okay, and also I want to do just the surface mesh, okay? Just to show you something, click there. And this is what we have, okay? But look at that here where we have the junction between these 2 surfaces. It doesn't follow that, okay? And also probably here, okay, here Cactus is a small mesh, but sometimes it might happen, and coming back to the OpenFOAM community, that sometimes in edges you have problems, some strange behavior. It's because we don't have that information. Probably here we have it, see here, because you don't have that. Okay, so the idea here is like, hit a snap, you get finer meshes, you capture everything. But the idea is the mesh needs to be economical, okay? I cannot have a 1 billion source mesh to resolve this problem, okay? It makes no sense. So look at what happens when I use a mesh where I have a geometry, where I have all that topological information. So I will pick this one, doesn't matter, okay? And I will apply same parameters, okay? So let me use here 0.05, 0.05, and on the surface meshing. And see that now it perfectly resolves that junction there between the surfaces that you don't resolve here. So the big question now is, can we solve that? Now I remember that in Snap and OpenFOAM we have something called feature edges. You need to extract those edges. Okay, and I would like to stress that we're working here with the Colada format, the STL. It might extract those edges. Probably you need more information, okay, but it's the same concept. So as you go here also, right click in your geometry, let me go geometry model, okay, let me erase that mesh, delete mesh, and right click here and see that you have this create feature edge. Feature edges, same stuff that you have in part of your OpenFOAM. So you give an angle and so on, and see that now putting 45 here, and the same concept, the smaller, the more features you capture. See that you capture those features, and now that you have those features, it will be able to resolve, in particular here. but here that is not complete, so probably we can go here and a smaller angle. Let me put 15 and see that 15, it closed this loop here. So now that you have that, okay, you can go back here and just to show you the difference. So see that now you resolve that well. Okay, so remember, geometry is very important. The mesh that you have, everything depends on the information that you are carrying now with the geometry. Okay, so pick up a good format. Okay, don't say STL or this format. Okay, you need to pick up the right format to have all that information. Personally speaking, I recommend the step format. Okay, it's a very good one. Also Parasolid, and then you have all the commercial ones. Okay, ProE, Solid Edge, AutoCAD, CATIA, all of those formats work fine. And IGES is not a good one. STL also is not a very good one. So people working with OpenFOAM get used to that format because it's what is used in the meshing tools. Even CF Mesh, that is another tool, but it's not a good format. Okay, so if I go here, let me go, this is what you have, this triangulation, so it can give problems. Okay, and something cool that we have here in Ennova is that this triangulation still can be modified, so we can go here in the mesh model and we can retriangulate and so on. A little bit more advanced and something that honestly you don't need, but just to let you know that you have that option. Okay, so that being said, I think I just wanted to introduce all the CAD formats, okay, and why it's important. Also here, okay, you need to create always volumes. Okay, when it comes in Ennova, have that volume. Okay, so let me go shade it. So check that you have always black lines, means that everything is closed. You have red, you can also have yellow and blue. Later we're going to talk about that and we're going to see how to fix those problems. Okay, but it's not a big deal. So remember, you select as surface, right click, and you're going to have many options. So to fix those problems, you see here, for instance, you have a hole in a face, you can fix that. Okay, you can select a face, you can select an edge. Same idea, you're going to have options here. So to change the selection type, you have here different options, or you have the shortcuts in the keyboard. So you select F, only faces, E, only edges, and nodes, and so on, and A for all. You can select everything. Okay, so this is this brief introduction. Okay, later we're going to move in a little bit more advanced, okay, how to repair this geometry. So go here, take a look at all the formats that you have. If you want to inform yourself, educate yourself, but for the moment I will say a step is very good format. Coming back to Eisen, and remember that Ennova is developed by the same people from Eisen, so it's a well-tested, time-tested technology. So you have it there also, you can read that format. Okay, so STED and ISIS and any of those commercial proprietary formats are okay. CATIA, SolidWorks, Solid Edge, Ideas, Unigraphic, okay, Space Cranes, I really like that one, and so on. Okay, so thank you for your attention and hope to see you in the next video. Bye.